Hi, my name is Emma Seaborn, and this is my video report for Lab 1 Constant Velocity. So, to begin, to start off, this is an introduction. The purpose of this lab was to observe an object rolling at a constant velocity across a flat surface and just observe the forces that are acting or are not acting upon it. So, to begin, to observe Newton's second law and the momentum principle, first, the net force and the change in momentum were both observed as 0. There's also no y or z component, as there's only movement observed in the x direction in this experiment. And the equations shown in the slide are the equation for the net force, or Newton's second law, and the momentum principle, or momentum. And so in this slide, there's an image of our experimental setup. There's a flat surface, a rolling object, supposedly without any forces acting upon it, and a calibration meter stick just to show the size of the object, height, and all that. And then, so this is a graph of the predicted motion, or the predicted position versus time graph of the rolling object. So if there were not alternate forces interacting with the rolling object, this is the path it would follow. And this shows the motion we observed, that we would think to observe during the experiment if there were no other alternate forces. And then this is our observed motion. This shows the motion we observed within the experiment. Using the tracker software, we pinpointed the position of the object in 0.33 second intervals to plot the respective data points in the x and the y. And show this more so, this is a representation of the respective data from the experiment from the tracker software, shown with the timestamps, the x values at that time and the y values at that time, and then also it graphed onto a position versus time graph. And then finally, this is a representation of the predicted data or path compared to the observed data or path. Evidently, the paths are very similar. However, there is a bit more variance in the data points in the observed path compared to the predicted path. And these differences could be attributed to, first, physical errors, such as resistance and friction acting upon the object and changing momentum, or also technical errors, such as not using the tracker software correctly and accurately, and just not pinpointing those the center location of the rolling object correctly. And so shown in this image is the code that I use in GlowScript to form a representation of the rolling ball and just solve for different components of this experiment. So to begin, highlighted is the rolling object's mass, which it was measured using a scale in kilograms. And then next is the rolling object's velocity and the x direction measured using the tracker software. Next is the time interval within the rolling object is being tracked. And finally, the two formulas highlighted are the velocity update formula to solve for the rolling object's final velocity and the position update formula to solve for the rolling object's final position. And the initial velocity was also solved using the formula on the right, and this initial velocity was 0.881 meters per second. And then in the slide is a image of the final code output showing the position versus time graph and velocity versus time graph, and there's an evident increase in position in the x direction, and a steady and constant velocity throughout the entire rolling portion. And then a visual representation of the ball or the rolling object and its trajectory. So next, this is just to define our system and our source. And so our net force is equal to 0 because the ball or the rolling objects, which is the system, is moving with constant velocity. And the summation of all the forces acting upon the object, gravity, friction, air, and resistance, which is our surroundings or our source, are equal to 0. And then when looking at what-if questions, just that we can observe with experiment, is one is flipping the axis to negative x. So if the axis was flipped and negative x was observed instead of positive x, then the magnitude of the position vector would remain the same, and the vector would just be pointing in the negative direction rather than the positive one. And here's my GlowScript code link, and in conclusion, thank you for listening, and